The Untold History of Arduino by Hernando Barragan. Why are you writing this? Hello, my name is Hernando Barragan. Through the years, and more recently due to the affairs between Arduino LLC and Arduino SRL, I have received a lot of questions from people about the history of wiring and, of course, Arduino. I was also shown this US Federal Court's website, which presents documents citing my work to support the plaintiff's claims, which, in my opinion, contribute to the distortion of information surrounding my work. The history of Arduino has been told by many people, and no two stories match. I want to clarify some facts around the history of Arduino with proper supported references and documents to better communicate to people who are interested about Arduino's origin. As well, I will attempt to correct some things that have distorted my role or work by pointing out common mistakes, misleading information, and poor journalism. I will go through a summary of the history first. Then I will answer a series of questions that I have been asked over the years. Why did you create wiring? I started wiring in 2003 as my master's thesis project at Interaction Design Institute Ivrea in Italy. The objective of this thesis was to make it easy for artists and designers to work with electronics by abstracting away the often complicated details of electronics so they can focus on their own objectives. The full thesis document can be downloaded here. Massimo Banzi and Casey Rees, known for his work on processing, were supervisors for my thesis. The project received plenty of attention at IDE and was used for several other projects from 2004 up until the closure of the school in 2005. Because of my thesis, I was proud to graduate with distinction, the only individual at IDE in 2004 to receive the distinction. I continued the development of wiring while working at the Universidad de Los Andes in Colombia, where I began teaching as an instructor in interaction design. What wiring is and why it was created can be extracted from the abstract section of my thesis document. Please keep in mind that it was 2003, and these premises are not to be taken lightly. You may have heard them before recited as proclamations. Current prototyping tools for electronics and programming are mostly targeted to engineering, robotics, and technical audiences. They are hard to learn, and the programming languages are far from useful in contexts outside a specific technology. It can also be used to teach and learn computer programming and prototyping with electronics. Wiring builds on processing. These were the key resulting elements of wiring. First, simple integrated development environment IDE based on the processing.org IDE running on Microsoft Windows, Mac OS X, and Linux to create software programs or sketches with a simple editor. Second, simple language or programming framework for microcontrollers. Third, complete toolchain integration, transparent to user. Fourth, bootloader for easy uploading of programs. 5. Serial monitor to inspect and send data from to the microcontroller. 6. Open source software. 7. Open source hardware designs based on an Atmel microcontroller. 8. Comprehensive online reference for the commands and libraries, examples, tutorials, forum, and a showcase of projects done using wiring. How was wiring created? Through the thesis document, it is possible to understand the design process I followed. Considerable research and references to prior work has served as a basis for my work. To quickly illustrate the process, a few key points are provided below. The language. Have you ever wondered where those commands come from? Probably one of the most distinctive things that is widely known and used today by Arduino users is their sketches. Is the set of commands I created as the language definition for wiring. Pin mode, digital read, digital write, analog read, analog write, delay, millis, etc. Abstracting the controller pins as numbers was, without a doubt, a major decision, possible because the syntax was defined prior to implementation in any hardware platform. All the language commands, naming and syntax were the result of an exhaustive design process I conducted, which included user testing with students, observation, analysis, adjustment, and iteration. As I developed the hardware prototypes, the language also naturally developed. It wasn't until after the final prototype had been made that the language became solid and refined. If you are still curious about the design process, it is detailed in the thesis document, including earlier stages of command naming and syntax that were later discarded. The hardware. From a designer's point of view, this was probably the most difficult part to address.